Alright, this is summation notation, and the equation is, so this is 2 minus I squared is the equation. 10
is the number of terms.
is the number of terms. I got this. I equals 3, which is the common difference.
And so what we have to do, we have to find the 10th term, like Sean said, I hope.
Yes, the 10th term.
Well, you said that. So what we do is we have to plug 3 in for I. And every time we plug...
And for every term?
For every term, for every time we go up, so after 2 minus 3 squared, we do 2 minus 4 squared, and keep going until you get to 2 minus 10. And we did that, and we, add it all together, we got this number.
Oh, wait, hold on. Is it arithmetic or geometric?
Oh, this would be an arithmetic series.
Yes.
Because there's the addition signs, and the common difference was 3.
Alright, so this is a arithmetic sequence, and that's because you're adding -5 to each one, and the equation is an equals a1 plus, in parentheses, n minus 1, close parentheses, d.
Also, it's a sequence because it's a list of numbers, it's not plus.
Yep.
Plus signs.
So an would represent the last term.
A1
which we don't know.
A1 is the first term, N is the number of terms, and D is the common difference.
Yep. So what we do is oh dang. Okay. I messed up. It's supposed to be 9. My bad. This is 9.
Alright. So
That's a 9, Soohoo. Alright, so
first we go into the parentheses, right? What do you call that? The order of
PEMDAS. PEMDAS.
Order of operation.
Order of operation.
PEMDAS.
Same thing.
So what we have to do is we have to do the parentheses in here first. Right? Yeah. So we do 150 minus
149.
comes out to 149. And then you have to multiply these first. I got it, Dylan. Chill. Alright, I got it.
That's awkward.
So what we have to do is you have to multiply this right here. And then 25. And you add 9, and you should get -736. And that's the answer. That's how you...
Alright, we're finding the 30th term here. This is a geometric sequence because it's a list of numbers, and we're multiplying by 4 every time.
Why? What is that called?
I just said a geometric sequence.
No, but why are we multiplying by 4? What is that called?
I don't know.
It's a common ratio.
The common ratio, yeah, I misunderstood your question. The common ratio is 4. The equation for geometric sequence is an equals a1 r n minus 1.
Okay, so what we do here is we have to plug everything in. So a1 would be the first term, r would be the common ratio, 30 would be the number of terms, which is 30, it says right there. And we're minus that by 1 because that's
what you do.
Equation. Yeah. Oh, and so what we do next? No, it's cool. You don't want to do anything. It's fine. And so what we do next is we do this first because you have to do that. And what's that called?
Order of operations.
Ask him though.
That's okay, because I got you.
That's what I said it last. 3 times 4 to the 29th power. When you plug this into your calculator,
You get a giant number.
you get a number that involves the letter E. Like this right here. And so what you do with that, is instead of putting the E there, you just do
Multiply.
You just hold on, Dylan. You just you just put the first, the hundredth. Where's the hundredth? Something like that.
Something like that.
Yeah. The hundredths or tenth place, something like that. You understand what I'm saying, Sue? You know what I mean.
The number has to be in between 1 and 10, and then point whatever.
So 3 times that.
Okay. In chem?
Yeah, in chem.
This is not chemistry.
Yeah, but it's the same.
No,
thing.
it's not.
Yes, it is.
And so
That's
what you do?
the same thing.
Whatever. And so after you do that, you multiply this by.
Flies everywhere, dude.
There's flies everywhere because we're so fly sweet. You feel me?
Hey!
So you do, you multiply this by 3, and you get 8.65 times 10 to the 17th power.
It's neither a geometric or arithmetic sequence or series because it's 3 times 4 is 12 and then 12 times 3 is 36. It's not the same common difference.
We have to find it's the apples problem. So we have 15 rows. We have to find the sum of the 15 rows. So what we do is we have 15 up top on the summation notation. I is going to equal 1, and the equation will be I squared. You do so you do 1 squared, 2 squared, all the way to 15 squared, and after you add everything up, you should be getting 1,240
Apples.
apples.
So this is summation notation, and we don't know what n is, the number of terms. So then you do the special formula, and n is automatically 15. So it's, yeah, you do that, plug in 15, you get that, and then you multiply everything, and then you get 7,440 divided by 6, and then you do that, and
We have to see how many. We have to see how much retirement money you will get at the end of 32 years. So on the first year, you're going to deposit 6,000. On the second year, because you are, you have interest rate, which is 7%, you're going to be multiplying this by 1.07. Same for year 3. So for year 2, you will get 6,420 because that's how much interest you have. And by year 3, you have 6,869.40 cents, and we have to find what we would get in year 32. So what we're going to use is the geometric series formula. The what's it called?
Common.
The common ratio would be 1.07, and your formula would be Sn equals A1, 1 minus Rn, and being the exponent over 1 minus R. And so we have to replace 6,000 with A1. R would be 1 minus, R would be 1.07, and the N would be 32 because that's the number of terms. So what we do is we have to do this first. Do the exponent first, which you would get 8.75. Sorry, 8.715. You subtract negative 1. I mean 1. Sorry, 1. You should get negative 7.715. Divide that by negative 1.07, and you should get 110.218. And you multiply that by 6,000, and you get 6,600. 6, right? 6,600.
661,308.93.
Thank you, Dylan. I had to thank you there. Problem number 8. We have to find what we are going to get in 31 years instead of the 32. So we do everything's the same except for the n is now going to be 31. You should get 8.145. Once you divide that, you should get 102.73. You multiply that by 6,000, you get 612,438.25 cents. And the interest, the compound interest over time would be 48,870.68 cents. Since we really didn't talk about the recursive rule, and how much you get added to your bank every year, this is the formula you would use for that, and that would be AN equals parentheses AN minus 1 close parentheses times 1.07 plus 6,000.
Reason the account grows the most in the last year is because it gains the most compound interest after year after year after year.